Hello, this is Math 10150 Lesson 4, the second video on solving quadratic equations. Last time, in the last video, we saw how to solve equations using the square root property, which said that if we have something squared equals something else, then the solutions are plus minus the radical of that something else. And this time we will be manipulating our quadratic equations that don't look like something squared equals something into looking like something squared equals something. And for that, please recall the common factorizations, that if we have a plus b squared, if we FOIL it out, it looks like a squared plus 2ab plus b squared. And if we have a minus b squared, that is a squared minus 2ab plus b squared. So it's important to recall these special forms. And so an example of this is something like x plus 6 squared is x squared plus 12x plus 36. And an example of something like this is x minus 6 squared is x squared minus 12x plus 36. So if our quadratic equation does not look like a trinomial that is factored into a perfect square, we need to readjust it so that it does. So when we complete the square, in order to complete the square for the binomial x squared plus bx, we need to add b over 2 squared. And now we can't just go adding things all over the place. Whatever we add to one side of the equation, we must make sure we add that to another side of the equation. And so what's going to happen is we have x plus b over 2 squared. Now b can be positive or negative, so it can be either one of these examples. Is going to be x squared plus bx plus b over 2 squared. So we're going to be faced with quadratic equations that don't necessarily look like something squared equals something, but through the process of completing the square, we're going to force our equation to look like something that we can use the square root property on. So let's see how this works in the first example. So sometimes you're asked to just solve quadratic equations, and sometimes you're asked to solve a quadratic equation using a specific method. So for example, we're asked here to solve by completing the square x squared plus 4x equals 6. You may double check your answer by using the quadratic formula or any other method you know, but if you're asked in a problem to solve an equation using a particular method, then that's the method you should use. So we start with the equation x squared plus 4x equals 6. Now remember what we must do to complete the square. Here we have a binomial. We have a binomial x squared plus bx. With completing the square, we must add b over 2 squared. In this case, our b is 4. So that means b divided by 2 is 2, and b divided by 2 squared is again 4. So this is kind of a slight mini computation. And what we do is we have to add 4 to both sides. So x squared plus 4x plus something equals 6 plus something. So we're going to add 4 to both sides. That is the only way we can add something to an equation, is to add something to both sides. That means we have not changed which x satisfy the equation. So on the left-hand side, I now have a perfect square because I added the precise thing to make it a perfect square. And on the right-hand side, I have a number. And now I can use the square root property. Square root property says that x plus 2 equals to plus or minus radical 10. Now I can subtract 2 from both sides, and I get negative 2 plus or minus radical 10. And these are the two solutions to this problem. Negative 2 minus radical 10 and negative 2 plus radical 10. And I have solved this equation by completing the square. I have added the appropriate thing to both sides to make the left-hand side a perfect square. X plus 2 squared is x squared plus 4x plus 4. I did not have a perfect square when I started this problem, but I added the right thing to both sides to make one side a perfect square. Let's look at another such problem. We are asked to solve by completing the square of the following problem. Two x squared plus 16x plus 50 equals 0. So we write down this equation: 2x squared plus 16x plus 50 equals 0. Now the first thing that I observe about this equation is that there's a greatest common factor of 2. So I can divide all the terms by 2 and I will not change my equation at all. The reason I do this is when I need to complete the square, I need to have the coefficient of x squared. I need it to be 1. If it's not 1, it's a bit more difficult to do the completing the square. So again, remember, if I have a binomial x squared plus bx, I need to add b over 2 squared. This is the completing the square operation. Although you don't have to, what I prefer to do is to leave only that binomial on one side and put the constant over on the other side. You don't have to do this, but I think it makes it a little bit more neater. And now what we need to do is we need to figure out what to add. We're going to add something to both sides to make the left-hand side a perfect square. Now in this case, our b is 8. b divided by 2 is 4. b divided by 2 squared is 16, our little side computation here. So that's what we do. We add 16 to both sides. Okay, so on this side, on the left-hand side, we now have a perfect square. X plus 4 squared is x squared plus 8x plus 16. And on this side, we add the constants, and the constants, negative 25 plus 16 is negative 9. Now we have manipulated our equation and now we're able to use the square root property. So now we have x plus 4 equals plus or minus radical negative 9. That's going to be a complex number, which we can simplify. So this, first we subtract negative 4 from both sides. And now we're going to simplify this complex number. continue here. So x equals minus 4 plus or minus 3i. So the solution is a pair of complex conjugates. Minus 4 minus 3i and minus 4 plus 3i. And this is the final solution to this problem. In another example, by completing the square, we're going to see an example where that b ends up being a fraction. So again, we're asked to solve by completing the square of the equation 3x squared minus 2x equals 21. Now the coefficient of x squared is not 1, and that makes completing the square a bit hard. So I'm going to divide both sides of the equation by 3. So then I get x squared minus 2/3 x equals 7. Again, recall the process of completing the square. If I have x squared plus bx, a binomial, I complete the square by adding b squared b over 2 squared. What's our b in this case? Our b is negative 2/3. That means b divided by 2 is negative 2/3 divided by 2. And that is negative 2/3 times 1/2, which is negative 1/3. And so b over 2 squared is negative 1/3 squared, which ends up being 1/9. Again, this is my little side computation here. So now I'm going to, I know what I need to add to both sides to make this work. I'm going to add 1/9 to both sides. Now on the left-hand side, I have a perfect square, namely x minus 1/3 squared. You can always double check. X times negative 1/3 twice is going to be negative 2/3 x, and negative 1/3 times negative 1/3 is negative 1/9, plus 7 plus 9. I'm going to rewrite 7 as a fraction so that I can add the terms with a common denominator. And now I have x minus 1/3 squared equals 64/9. Going to continue here. I'm going to take the square root of both sides using the square root formula, and I'm going to get plus or minus square root of 64/9. So that means x minus 1/3 equals plus or minus 8/3. So this means the solutions are x equals 1/3 plus or minus 8/3. I can simplify this. X equals 1/3 minus 8/3 is going to be negative 7/3. And x equals 1/3 plus 8/3 is going to be 9/3, which is 3. So the final solution to this equation are the numbers negative 7/3 and 3. And yes, you could have probably done this equation by factoring, but it's not obvious right away, and the methods of completing the square or the quadratic formula will always get you the correct answer. In the next problem, I'm going to solve by the quadratic formula. So solve using the quadratic formula. The following problem: 5x squared plus 4x minus 4 equals 0. Now recall the quadratic formula. The quadratic formula says that the solutions are of the form minus b plus or minus square root of b squared minus 4ac over 2a. So when we use the quadratic formula, it's up to us to properly plug in all the variables and then simplify. In this problem, we have a equals 5, b equals 4, and c equals negative 4. So our solution is x equals minus 4 plus or minus square root of 16 minus 4 times 5 times negative 4. Be very careful with signs here. Put everything negative inside of parentheses, divided by 10. Now I'm going to simplify what's under the square root sign. This is negative 4 plus or minus square root of 16 plus 4 times 4 is 16. 16 times 5 is 80. So this is 16 plus 80 divided by 10. Since there's a lot of negative signs here, I do advise to only simplify with one step at a time. So this is minus 4 plus or minus square root of 96 divided by 10. Our answer looks simpler, but that radical of 96 can be simplified further. This is x equals to minus 4 plus or minus radical 16 times radical 6, since 6 times 16 is 96. So now we have minus 4 plus or minus 4 radical 6 divided by 10, and we can factor out a 2 from the numerator and denominator and get our final answer to look like this. So the final two solutions are negative 2 minus 2 radical 6 over 5 and minus 2 plus 2 radical 6 over 5. And this is solving the problem using the quadratic formula. We will do one final example with the quadratic formula. Solve using the quadratic formula, the following equation: 3x squared minus 2x plus 2 equals 0. And again, it's good to label what A, B, and C are. A is 3, B is negative 2, and C is 2. So the solutions using the quadratic formula become minus b, so 2, plus or minus b squared, which is 4, minus 4, 3 times 2, divided by 2a, which is 6. So this becomes 2 plus or minus square root of 4 minus 24 divided by 6, which is x equals to 2 plus or minus square root of negative 20. This means our answers will be complex numbers. And so we have x equals 2 plus or minus radical -1 times radical 20. I'm doing this one step at a time. X equals 2 plus or minus I times radical 20 divided by 6. Now radical 20 is not in its most simplified form. This is x equals 2 plus or minus I times radical 4 times radical 5 divided by 6. So we have x equals 2 plus or minus 2I radical 5 divided by 6. And we can factor out a 2 from the numerator and denominator and get 1 plus or minus I times radical 5 over 3. And these are the final two solutions. 1 plus I times radical 5 over 3. And 1 minus I times radical 5 over 3. Now if I wanted to write them in formal a plus bi form, the solutions would look like this. 1/3 plus radical 5 over 3i and 1/3 minus radical 5 over 3i. When you enter your answers in the online homework system, they may require you to enter them like this with the fractions separated. Again, you can verify this by solving the quadratic formula using completing the square. If you get the same answer, chances are you were correct.